Okay, so let's switch gears. We're going to talk about precision measuring, torquing, and safety wire. I know. So again, I'm following behind you guys. So I've given a lot of you like the really quick lesson here in how to read a micrometer. We'll slow down, let you take some notes, do it again. Micrometer is units of experience, and trust me, you are going to get a lot of experience coming up in the next class. Well, let's see here. We can skip some of this. I'm going to do notes just a little bit different. So, all right. But we start talking about micrometers. We're going to start talking about very small numbers. So, of course, we know that 1 inch can be written as 100, right? 1 inch, 1.00. We're going to be talking about things down in the thousands and 10,000s. So when we talk about decimal, we have, well, we'll go places. What place is this right here? Okay, so that's tenths, T-E-N-T-H, tenths. And this one is hundredths. Hundredths. This place here is the thousandths. Thousandths. And then this one is the 10 thousandths. 10 thousandths. DTA, 10 thousandths. And so as aircraft mechanics, especially engine mechanics, we live down here in the thousands and 10 thousandths world. That's where we're really trying to find differences and nuances down in this area. But you have to get used to kind of the speak, so to say. I'm okay. I'm one of these guys. If we can understand each other and you're not saying something wrong, then I'm kind of happy. So if it's always easier for you, if you had, if you said, well, Kevin, it's 1.1234. I can understand that. I can write it, and there's no ambiguity about it. I'm okay with that. Actually, it would be a little difficult if you said, well, it's 1 inch, 120, 100, well, I can't even say it. Yeah, it's 10,000. It's 1,234 10 thousandths. Like, well, slow down again. I got to think that one through. So, that becomes a little difficult. But then I make things hard. So I could say that this is, let's do this, 0.000, let me try this again. 0.001. What is that one called? What would I say that is? 1 thousandths. Okay, everybody knows that. Okay, what is that? I'd say 1.5 thousandths. See, that's just the speak that I grew up with there. So that's 1.5 thousandths or so. So then what would this be? Half a thousand. I think I just put one too many zeros there. Yes, there. So we'll put that there. So 0.0005. So this number here is the thousandths. This is tenths. So you could say 5 10 thousandths. I would say half a thou. So you kind of get, I'm sorry about it, you kind of, maybe I shouldn't do that, but that's the way I've talked for so long. So, if we're talking about something, oh, it's just half a thou. It's 5 10 thousandths, 1/2 of a thousandth. All right, because honestly, when you're getting down here to the 10 thousandths, it's kind of hard to really nail it down. To be honest with you, you can and I'm going to show you how, but temperature variation in parts changes it to the point where if you're really stressed, is it 4 10 thousandths or is it 5? Ooh, maybe it's 5.5, so almost 6 10 thousandths. All right, take it into the next room. Wait a second, it's going to change. So when I was doing machine work on stuff, even cylinders, I could never do a final bore on cylinders until the next day. I had to wait for them to sit all night long and get to room temperature because the heat would just change it. A room that, I could see crankshafts change by a thousandths or so. So super cold crankshafts, they would really kind of shrink up, if they sat cold soaked all night. So I kind of tend to default. I don't want to say round up or down, but if it's anywhere near a 5, I usually call it half a thou. So, all right. So anyway, so if we can get our decimals square, and we know our decimals are good. Let's talk about some of this. Well, we were talking about that. How thick is my piece of paper? Probably a little more than 3/1000 of an inch. So it's funny when you really think about that, and you know, you're out there building an engine and you're really worried about something that's plus or minus 1/1000 of an inch. In fact, it's funny, I had somebody who wasn't familiar with aviation was trying to manage the shop, and it only lasted for about 2 weeks. He came in, he said something about, you know, something was off, the machine was off by 1/1000. See, there I go. So it was off by that much. And I was trying to calibrate it out. He's like, are you fucking kidding me? You know, you're splitting hairs, dude. And all the other guys in the shop backed up like, ooh, that's what he does. Don't tell him that. He knows. So, yeah. Yeah. But, so, okay, so what was it? Paper thickness. So how thick is a piece of hair? Somebody pluck one out. Let's see.
I need all the ones I got.
Yeah, you got some in the back, don't you?
My back here?
We could pluck one from Zeus right off my shirt. He's probably got more. So hair, about 4,000. So you have any on him? Tail hair? No. All right. So what else did I have that was fun? Aluminum foil, heavy duty. Somebody else asked, light duty or heavy duty? He says.
What?
Heavy duty aluminum foil. How much? 1,000. That's actually the smallest.
That's thinner than a piece of paper?
Oh, yeah.
Okay, I can see
yeah.
that.
All right. All right. So what is the tool we are going to use?
Micrometer?
It's called a micrometer, actually.
Well, that's what I keep pronouncing. I keep hearing micrometer.
It's
like,
micrometer.
I'm saying it wrong. Okay, so I have been saying it wrong. Okay.
It's micrometer. And now I'm going to start saying it wrong on accident, so I don't mean to do that. All right, so micrometer. Don't pay any attention to these numbers because this was the best looking picture I could steal off the internet, and it's metric. Okay, so, but we want to be aware of some of the things on here. And so, number one, carbide tipped measuring faces. What is a carbide tip all about? Very hard. Much harder than the stuff that you're measuring so that it doesn't wear. That also means carbide, these little sharp edges will really scratch the heck out of something. So be very careful when you're putting it on and around like a crankshaft. Don't jam it on there, right? Because this will damage a crankshaft. These little anvils right here. So we have the anvil that stays and the spindle that moves. Notice this right here, heat insulating handle. What do you suppose? These things get hot? Is that what I'm worried about? Yeah, the heat from your hand can actually expand and contract it. So you want it to stay the right temperature. A locking device, which it should work. Most of ours here do not. I'm very sorry about that. We have a vernier scale on the back. Not all of them have a vernier scale. We have the sleeve, or what is this one? I think this one has another name on it. Sometimes they're called the barrel. Sleeve, we have the thimble, which is the part that moves. And most importantly, not most importantly, but importantly, I want to point out that they have a ratchet on them. And the ratchet is a very important thing that you should use correctly. All right? It's really easy to use this correctly. It's even easier to use it incorrectly. Bad habits, weirdness, things that don't go well. So what we got to do is we got to learn to read it. We got to read it correctly. This particular one is a 0-to-1 outside micrometer. And I want to stress that. It is a 0-to-1 outside micrometer because these only measure in 1-inch increments. There. So if you want something, you want a 0-to-1, you need to go to the tool room and ask for a 0-to-1. If you're measuring a cylinder, you're probably going to be asking to a 4-to-5 or maybe a 5 to 6 inch micrometer. If you ask James for a micrometer, he will give you a micrometer. Yes, you can get this one and say, oh, you want a micrometer? Here's a micrometer. I don't know what you need. So that's a very big micrometer. So don't ask for a micrometer. What's that? How big is that one?
It's just like, it's so small that like, what would you use to measure that? Like,
small? No,
well, no,
this
like,
is not. This is a normal size one.
No,
oh.
I'm saying like that the pole is really small, so you have to be measuring something really big with like very little difference. So.
Oh yeah, it's a very large thing with very. Okay, so what are we gonna do here? All right, so we've got the sleeve scale and the thimble scale. Now I'm gonna try and. I was gonna put on a little table, but the little camera right there doesn't work over here. So I hold it like this. Can you see it? Okay, so we have the thimble scale, which is up on the screen right there, and the thimble scale reads in what increment?
10,000.
It reads in thousands. Let me see if I got this pen. This reads in
Oh, yeah.
0.001 increments. So I have right here, this little thing right here. Now, if this was a 0 to 1, and I close it all the way down, in a perfect world, I might see a little bit of that 0 line there, and I would see this 0 line. I would say, okay, it's all the way closed, my 0 to 1. And it's measuring how much space? How big is that thing I'm measuring? Nothing. The anvils are touching each other, right? And so I like to take a micrometer and kind of close it up, look at it, and make sure it looks like that. Let me get a micrometer here. See what I can pick up here. I want one that makes a ratchet. Oh, I've got nice ones here. Okay. So, hear that? All right, that's the ratchet. So, you need to use the ratchet correctly, and its purpose is so that you have repeatability and you're not over tightening. So if you tighten this too much, it's just going to force the micrometer open, and it's going to give you a false reading and damage the micrometer. All right? But what you can't do is force it closed with your hands and then do this, because you've already closed it too tight by that point. So it's funny. Last class, they all did that. And it's tight and go, oh, perfect. No, that is not perfect. All right? That was completely and totally wrong. You have to actually bring it up until it clicks. Now, there's no need to do this.
Once it clicks.
I saw a girl at the gas station with her gas cap. I'm like, stop. All right. So if it clicks a little, you're done. All right. But you can mess up pretty. Let's see. I need somebody to help me out here. Oh, I have a crankshaft here. Hey, Philly. All right. You guys see this okay? Well, get taller. All right. How about now? I'll try to do it here. See okay? Okay, so I bring it on here, and so I might do a little bit, make sure I'm on there quite right. And I'm going to lock it, and I'm going to slide it off real careful. You should feel it slide off real nice. And if I use the ratchet, it should be just the perfect tightness. But you can make a mistake. So I'm going to put, does that look like I've got it on correctly?
No.
Ratcheting. Lock it. Am I getting a good measurement? No, of course not. It's not right. Okay, so you have to make sure that when you're putting it on, that you're actually, I think I got the wrong size here. I do. Happen to. Make sure that you're getting it on there square and not lopsided. And nice and gentle. There we go. What am I going to do now? Lock it. And feel how it slides off. Or maybe I want to try and rock it this way. Just a little bit. Does it rock? Yeah, it doesn't rock. Because what I'm going to do is a lot of you, you're going to do it. And I'll say, well, go ahead and measure that rear main. You're going to do that. And I'll say, let me have it. And I'm just going to take it and I'm going to put it back on there. And I'm going to see how it fits and if it rocks. And if you give it back to me and I put it on there and go, well, that doesn't seem quite right, does it? And I'm going to ask you to do it again.
So, how when you put it on there square, is it marked on?
There's no markings anywhere. You just got it. So you don't want it sitting crooked.
No.
Just kind of feel it. And that's maybe why you're hitting a few more clicks than just 2 clicks. I'm actually kind of wiggling it this way, just making sure it's sitting on there just nice. It's really easy to do. Quite simple. And then slide it off. All right?
Another question I had.
Yeah.
Speed scale, is that the same thing as the barrel?
Yes.
Okay.
Yeah, because I think one of your books calls it a barrel. All right, so I don't know what that was about. All right, so this right here, the thimble is reading in 0.001. So I've got this one lined up here, and if I move it just one little line, how much have I measured? I can't see that, so you just have to trust. 1,000. All right. So now, of course, this is 40 threads per inch, and it's designed that way. So as I move it, it's going to move away from the 0, right? And so I bring it around, and how much do I have right there? 10. So 10 thousandths. It's
Actually,
point.
100. 100.
It's supposed to be around the 10. Sorry. So point what? How many thousandths? 0.010. So how many thousandths? 10 thousandths, right? So we say 10 thousandths. That's funny. That's how we'd say that, 10 thousandths. Okay, so I'm going to set it down. So,
100?
no, we say 10 thousandths. I know. What do you want to say?
100.
Oh, 100th? Yeah, in machining we don't say that. I don't know why. All right, so we'll bring it around over here.
Then that would be very. It's like, yeah, we have 10 thousandths of an inch, and then it's like, yeah, we got 10 thousandths of an inch.
Now, some people would say that's
one in the 10.
110 thousandths. And it's like, okay, come on, now you're just making me nuts. All right, but it's accurate, and that's what they say. And so you got to think it through. All right, so how much do I have there? 21? Okay. 0.021. I forget what I put on there. All right, 0.21. All right, so you guys are figuring this out. So now if I keep going around, there on the thimble, there are 25 marks. 0 through 24. This one's 24. 0 starts again. It stops. Must be also 25. So once I get around to the next 0, I should start to see a little line right there, letting me know that I've moved a long way. One whole turn around. So if I bring it up to that, how much do I have? 20. Okay, 0.025. Now I recommend that you start that you don't necessarily have to read it and give me a number. You can write stuff down. So what do I got right there? Okay, so I like to add it up. So I start with the big numbers. I've got 0, so I got 0 there. I won't count that. And so I got one line. So how many is that one line? Tell me. 20. Okay, 0.25. 0.025. Then how many do I have on the thimble? 0.007, and then add it up. Oh, I should use easier numbers. So 0.032. All right. Now, of course, remember, so I've got one line here, which tells me how much? 25, and the next one is 50, and the next one is? Then I get to 1. So if I line this up over here, let's go like that. Stop. Okay. What is that?
162. 1.062.
Okay, so let's start here. So I've got this, so I'm going to add in that. I just add it up. That's point what? 0.1. 0, 0, 0, just whatever. Okay, how many of these do I have? 2. So that's how much? 0.050. So you got to make sure you have the right number of zeros. Then how many do I have on the thimble? 12. 0.12? 0.012. All right, so add it up. 2, 6, 1. 0.162. All right? All right, you guys are getting good at this. Let me think here. Okay, what do I got here?
4.
What's my first line? I can't remember what I put. What is it?
0.193.
Point. No, not the whole answer. Let's do it. Point. What?
0.100.
0.100. Then what?
Then point
0.75.
0.075.
I'm gonna listen to you. 0.075. I can't see it. Then what?
Then it's 0.024.
0.024. So you're telling me when I turn this around, I should see 1.99.
No.
1.98.
Should be 50 thousandths for the.
Well, that's a 5 and a
The last number should be 23.
23.
23. Oh, man.
Yeah, that's what I'm.
It's
Trying to trust you guys.
0.050.
Well, is this number right?
Yes.
Is this number right?
No.
Ah, it's not right.
Depends on the side of the class you're asking.
Okay.
Yeah,
Can't see it?
that looked like 0.075 million.
Okay, let me tell you why it is not 75. How many lines do I have showing here?
3.
I got 3. How many can you actually see?
Yeah, you can see.
You can see 3, but that doesn't mean it's 75 because watch. If this was real and I move it just a little bit, how much is that? That's 75. But I'm going to move it backwards too. So is it So it wasn't 75. It's coming up on 75. So just because you could see that black line does not mean that you automatically add it. You got to be smarter than the micrometer or micrometer if you want. So it's really, you can only count those two lines because that is all that we really have going for us there. So, pen. So it's really 050. It's about to go 75. Now, this is what I refer to as the personality of the micrometer. In a perfect world, you wouldn't really have this problem, but if the line is fat enough, you're going to see a little bit of it before it gets there. You can't really design a micrometer so you got nothing, 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 and oh, right there, you suddenly get the line. It's a little hard to do. All right, so you might see the line, but you got to think it through. Go, wait a minute. If that's on 23 and it's coming up to 0, then it should be a long way away, right? If you're going to give it 75. It's got to be way down there if it's 75, so it's only 50. Yeah.
So obviously for the class we want to learn how to read the micrometer
Yeah.
analog. But in the field, are digital ones typically reliable, or do you think that they don't read super well?
I didn't use digital.
Okay.
I use this.
Okay.
I can read them faster, and it worked for me. And I don't know, but then again, back when I was doing it, they didn't have, you're talking actual digital LED display. I didn't have that when I was doing this. They were like a mechanical odometer, and they weren't, I don't know. I didn't need that. So sure, if you want to, I have no problem with that, but you got to learn to do this. So yeah, in the field, get whatever you want. Things are changing, so use technology, embrace it. But boy, wouldn't it be a shame if you got to the mechanic examiner and he asked you to measure a crankshaft and hands you this and you couldn't do it? So, and I also hate to burst your bubble, but when you get into electricity in a few weeks, guess what kind of meter you're going to use? Not digital. You're going to use an analog with a needle, and I'm going to make you learn to read that thing like you wouldn't believe. Why? And so I asked my students, by the way, before I did this, I asked a couple students, I said, hey, you just had your mechanic exam. Let me ask you what kind of meter the examiner made you use. Had to use analog and digital. Had to show that you could do both. So you'll learn. All right, so anyway, that's my point on that one. So we have, and then what do we have there? 20, how much? 23. So 183? No, 173. 173. Now my paper looks like your paper. You guys do this. Use a dang pencil, would you? Sorry. All right. All right, now how much?
81.
I got the top.
5.
Okay, so we've got 0.1. I'm not trusting you guys. 0.1. Now what's my next line? 75. 75?
No.
075. What's my next line?
You gotta show the top.
0.115.
Veneer side.
All right, so somebody's yelling, veneer side, veneer side. How much do I have on the thimble? How much this line right here?
0.115.
011. All right, now, it's in the middle. So we just round up or down?
No.
No, we don't round up or down. We get exact as we can. If you don't know any better, just take a guess. So if I had to guess, I would say it's, I hear 5. I hear 4. Well, if I had to guess, and you had to guess, I guess whoever wants to guess is good as the next one, right? But we have the veneer scale, okay? So this reads in 10 thousandths. So the way we're going to read the veneer scale, we don't look at these numbers anymore, but we look at the lines. We look at these lines and figure out which one lines up. So which one lines up? This one right here lines up about?
4.
They don't all line up. Only one of them does.
Wait,
Back there?
Where?
Well,
Huh?
3 and 4 does.
Okay, which line here lines up with which line here? Do you see any of them lining up?
Yeah, 4.
The 4 lines up. So we looked at this line, 6, 5, 4. So if this line right here, I can't see, but lines up with one here, then it's 4. So now we're not guessing anymore.
Did ours have those?
Some have them, some do not. All right, so we don't guess when we have a veneer scale. We actually put the right number. So how much is that number right there? It's 4. 0.4? 0, 0, 4. 4 here?
Zero.
Another 0?
Four.
4. All right, so 4. We've got 6, 8, 1.864. That's not hard, is it? Okay, the hard part of doing this, number one, is really just getting it on the crankshaft correctly, or the part correctly. That's hard part number one. Number two is knowing when not to count something. Just because you can see a line and then counting it in there and say, don't do that. So you have to say, ooh, that line's not ready yet. I can see it, but you can't count it. And some of them are even worse. You should be able to see the line and you can't. You're like, oh, it's got to be there somewhere. All right, so, this is just kind of an exercise in that. What does this one read here? So we got 0.2. How many here?
1.025.
0, 2, 5. Very good. My thimble is next. This is the thimble. 0.001.
I'd say it's 0.0006.
So that's 0. So 6?
Yeah.
2.
2. 0, 0, 0, 2. So 2, 6, 2, 2.2262. All right. Oh, there's our sheet with that stuff. I think you guys have figured this out well, and I've explained it how to do it. Okay, so you would think, when I wrote the project sheet, wouldn't it have made more sense if I would have said new max, then new min, then service? Because then it would say 1.8730, 1.8720, 1.870. So anything between here and here you can clearly see is what? New. And anything between smaller than this, that is serviceable. Wouldn't that be a much nicer way for me to write that? That's not the way the manufacturer wrote it, so I made it just like they did. And by the way, that's not a Continental crankshaft, that's a Lycoming, but don't tell anybody. It's just the best one I could find. So, all right. And so then I'm expecting you to fill all of this out. So if my crankshaft is 1.871, is it new, serviceable, or out of limits?
No.
Serviceable.
Oh, wait.
Yeah,
Yeah,
Serviceable.
Serviceable. All right, I tried to make this easy for you. In the next class, I'll expect you to do this. You have to take measurements in 2 planes. And so the way I would do it is, I don't want to confuse you. I would take the bigger measurement, I would write it down. So because it's going to wear small. I'm sorry, take the smaller measurement. Take the worst. I want the worst measurement all the time. So of any one, I'll take the 2 measurements, and let's say it was 1.871 in one dimension, 1.872 in the other dimension. Which one's worse?
7.1.
Okay, so this one is the worst. So I would write that, and then the next one, I would write my measurement, I would just say plus 0.001, which means it got bigger the other way in 1,000ths, and so the difference between the two is 0.001. I'm just going to confuse you. I'll explain it next semester on how to write it down and how to make it work well for you.
So
You'll
then,
get it.
that second part there is it'd be plus 0.001.
So
that would be.
Okay, the difference between these two is 0.001, right? That's just all you need to know right now. Let's just do that. So
Okay.
take the biggest, take the smallest, the difference between the two. You should always write down the worst. We don't want to write down the best, because what if it was 1.872 in one dimension and 1.871 in another? Well, I just did that, so I don't have to worry about that. So if I use this one down here, is it new? I can't change my pen color easy. Is this one here new or serviceable? 1.872, new or serviceable? This is new.
Yeah.
Is this one new or serviceable? So on my piece of paper, would I want to be looking at 1.872 or do I want to be looking at 1.871? Well, if I'm the owner, I want to. But as the mechanic, I got to go worst case scenario. I could do even more worst case scenario. What if these, let me see here. What if my measurement is 1.870 and 1.869? And I write 1.870. Is that new, serviceable, out of limits?
Well, serviceable.
Serviceable. What is this one? Oh, well, out of limits. So if I wrote down 170, then what would I write here? 0.870. What do I write here then?
Serviceable.
Serve. Serviceable. It's fantastic. Is it serviceable?
No.
Nope. It's got to out around a 0.001. Hey, we're looking good. Everything's fantastic. Is it fantastic? No, it's actually out of limits. So don't write that. You should have wrote 1.869 out of limits.
So say for instance you did put the 1.870
Mhm.
and then serviceable and then the out of round you put 1.869. Would you put like the difference would be
Yeah,
would be
sure.
like
It's just,
negative?
it's
So-
just how you do it. It's just how your sheet is. I just want to bring this point. Make sure you write the worst, not the best.
Okay.
Okay.
I was wondering though, like if you do actually
Sure,
write it
you-
the other way,
you coulda wrote it-
put negative.
Yeah, you could have wrote. Yeah, yes, you can. There's ways to do it, but just make sure you
Okay.
do it in a way that everybody understands. All right. Going across some other tools here, we have veneer calipers, or we can also have dial calipers. There we go, dial calipers. I don't think we'll be using them in this class. I don't really use these as precision measuring instruments per se. I guess maybe that's why I'm bringing it up. Don't try and use these to measure a crankshaft or something like that. These right here, they're a little more flexible than I like them to be. They work really well for measuring what I would call like a nominal thing. And by that I mean if I had 3 pieces of sheet metal and I wasn't sure which one was 032 and which one's 040, this works great. I just got to get in the ballpark. It's 03, I don't know, 2.5, it's 032. Right? So this works good for that stuff, but not for precision measuring of a crankshaft or the stuff we're doing. All right. This might be a little difficult to catch on camera, so maybe I won't. If ever there was a tool that I hate, it is the T-gauge. I think they are crap, and I'm saying it for the record. All right, and and I'm going to teach you next semester. Some of you guys may have saw me doing it out on the bench today earlier. I did 10 cylinders in, I don't know, 1 minute once I was set up. Extremely accurate, no question about it. So there are much better ways. To me, this is you come up with an extremely accurate number of something that you weren't accurate to begin with. And the reason why, and this is probably one of the hardest things I have to explain, is the way a T-gauge works is you're going to put it here in the cylinder, and you're going to hope that you have it perfectly parallel, and you're going to hope because, let's see here, because it's something that's round. So we're trying to measure something that's round. Okay, this is not going to be round. Well, let's just pretend like it is. It's harder than you think to draw on this. So we put our T-gauge in, and we hope that, but what if I've got it coming like this? Did I actually get the center of it?
No.
No, I'm exaggerating, but that's exactly what's happening. And then we've got it, in the other dimension, we have the cylinder walls, and then we've got our tool going this way. Is that giving me an accurate measurement? I'm exaggerating. No. So you've got it off to one side and crooked, and then you're going to measure and go to the nearest thousandth of an inch. Okay, it doesn't work that way. So it's very difficult to use this, and some of these are getting wore out. They don't work well. So here's just some ways to cheat, okay? So number one, try not to go, all right, because it damages the tool, and it's really not good for aircraft parts. So first of all, I start with it. This is not going to be easy. Unlocked. It wants to lock on me. And I start with it not center. You can see I'm got a serious angle there, right? Okay, so I take that serious angle, and I kind of anchor one end where I want it. And I want this when I measure it right even with this flange. Can you guys see the flange? So I want it even with the flange. It's about 1 inch down. It's where the book calls for you to measure it. So I kind of hold one end, and I pull it until it looks as center as possible. And the reason why is because if I'm way off, like I've got on this picture right here, this picture here, it tends to pull it into the middle really nicely. So I'm going to put it way off to one side. I'm going to pull it up, and it just walked itself right in the middle. I'm sorry you guys can't see that real well. So anchor one side, pull it, and then I will eyeball it and say, okay, so one part should be even with right here, and the other part should be even right here. So again, bring it up, through, and it kind of finds its own center, and take a look at it. Up here, lock it in, lock it in, and pull it out. Okay, make sure it's locked. All right, so now it's locked. Now, don't measure it. Try it this way. Put it back in, hold it, and see if you can take it and move it through the cylinder on its way down. Because there should only be one spot and one spot only where it's going to fit just perfect and make it through, right? Think that through for a minute. So if it's a little bit too small, it can fit all the way through and go clink, 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 all the way down, right? You'll get to the perfect apex where it's perfectly parallel, but you can still move it back and forth. That would be bad, right? It means you're too small. And if you were too big, you can't drag it through. You won't be able to start at the top and go through. So if I did that, let's see how well I did here. So go back and forth, back and forth, back and forth. See, I can actually make it go all the way through and not even touch the cylinder. So what does that mean?
Too small.
It's a little too small, all right? So I try it again, try again. So I keep doing that until I got it exactly how I wanted it. And for the sake of argument, let's see. Well, that's still a little too small. So I get it exactly right, and I've tested it and I felt it. Because when I work with you, I'm going to ask you to do it, and you're going to do this part and say, "Let me see it." And I'm just going to walk up to it, and I'm going to go through like that, and go look it. I can make it all the way through the cylinder and never once touch the sidewall. So this is too
Small.
so you should do that, okay? Then, once you get it and you're perfectly happy, here comes the second hard part. If you squish down on it with this, you're going to make this smaller. They don't lock very well. So you have to hold them very carefully. And honestly, I don't even use the clutch at this point. I don't trust that clutch. I bring it up, and I touch it, and I give it just a little peck, just a little kiss. Katie, help me out.
Like you're kissing your sister.
Thank you.
What?
So
I
Madagascar.
didn't even do that.
So just look at it, barely, just a little peck, just a little kiss. It's from Madagascar. All right, so just barely touch. I won't even use the clutch because the clutch puts too much pressure on it. And what I start doing is I got to get on there. I'm doing it. Well, how come it just keeps getting smaller and smaller and smaller? I don't know the clutch. And so all you're doing is just compressing it down. So all right, so it's just as barely, it's just the slightest little peck. Then you're gonna set that down. You're gonna read it and take a measurement. Okay.
So that one doesn't lock very well.
This.
Yeah.
It kind of no. It's really
I'm gonna come in early.
coming
that
loose
day,
down here
right?
every time I touch it, instead of up here, which makes it really difficult to use. So
And that thing's also seasoned as well.
yeah,
Gee.
that's
Got shot.
that didn't happen.
James.
I know.
Precision.
So
See, I'm coming in early that day because I'm gonna need a little bit more time on that.
yeah. All right. So I do not like these. Because now you broke this one. Yeah, the part's done. And so
So
that
is there
that
something else to use besides that
Yes.
particular tool?
yes, but you're not going to get to use it.
Oh.
Okay? So
Okay.
next semester, I'm going to teach you how to do it with some much better tools.
Oh, okay.
All right? But not,
Give us the bad stuff right now.
but not, well, this is what's out there. And I've been to shops where this is what they're using. I'm like, oh man, that is not fun. Okay, so you got that. So you got to start, you got to bring it through, and then double check yourself. Don't just take it out and measure it. You've got to go back in there and see, how does it fit? How does it feel? All right, so the real way to do it, I'm going to use an inside micrometer and either read it direct off the inside micrometer or transfer it onto an outside micrometer because I can put it in there and adjust it by just little tiny, by tenths of thousandths of an inch. And I do the same thing with an inside micrometer. I feel it going in, feel it. Okay, that's perfect. That's exactly where I want it. Take it out, read it. Then I can set up a bore gauge, and I can use a bore gauge to read it from there. So. All right, so that's that thing. We also have ball gauges. These are actually half ball gauges. The picture shows a ball gauge. So ball gauge is actually a reasonably good tool. A half ball gauge is actually a reasonable piece of crap. So, but the way it works is you expand the little half ball here. If it's a full ball, like in the picture, they work so much nicer. And so you just expand it. So I want to measure the guides here. So these are guides. And on a cylinder, there's the exhaust side. The exhaust side always has a lot more fins on it because the exhaust side gets really hot. So it needs to get rid of that heat. So look for the side of the most fins, and that's that side because it's got all the fins. All right, and this side has less fins, so that must be the Intake side. All right. Also, exhaust guides are bigger on the inside and intakes are smaller. So, all right. So to measure that, I'm just going to put it in, and you would expand it just a little bit until you get a nice snug feel in there, and then pull it out. Now you have to be kind of careful because exhaust guides actually wear, they don't wear straight, they kind of wear, I'm exaggerate, in sort of a bell mouth. And so this right here is the top right here, and down here is inside the cylinder down in there. So if I take a ball gauge, or half ball gauge, and I've expanded it across here, and I'm trying to pull it out that way, what's going to happen? Yeah, it doesn't work that way. So the real way to do it on these, and work out in the field, is to get it down more in the lower thirds, because it's going to wear down there, and I want to find the wear, right? I don't want to find out where it's good. I'm going to get it right about there, and then I just bring it out the bottom and catch it. And then I'm going to measure it. And of course, they're a little springy, and so if you tighten it up too much, it doesn't work. So,
Can you use the micrometer for that?
yes, of course you would. Then you'd use the micrometer. Just take the 0 to 1. I don't have one next to me, but take the 0 to 1, bring it down, measure it. There's your reading. These are easier to use than a T gauge by far, because just the way they operate. All right, ball gauges. Oh, this is a dial indicator. We will use those next semester, not in this class. That's what a bore gauge looks like, and they're really neat, and you're going to love it. And once I show you how to use a bore gauge, you're going to hate me for ever making you use a T gauge. But you can't use bore gauge in here because they break really easy. And feeler gauges, we're going to use those next semester. All right, that is an awesome place to stop right there. So let me see. Is there anything we need to write down? Anything we need to write down? All right, linear, micrometer, we did that. T gauge. I know I didn't write a lot of notes for you tonight. You gonna be okay with that?
Yeah.
Okay. Ball gauge, ball gauge. About what size can I use a ball gauge up to? About how big do you think?
Half an inch?
About half an inch. 1 inch, half inch. So anything bigger than half an inch, what tool would I use next? T gauge. All right.
Wait, they have a T gauge for anything over a half inch?
Yeah, here's a T gauge right here.
I've never seen. Dang.
Okay, there's something I can make up, and I call it a GoNoGo Gauge. This is a great way to cheat. So if I had something,
Why are you telling us how to cheat?
You don't like cheaters?
I don't know.
Could help us out.
Because okay, so for example, if it said this particular guide right here could not be any larger than a certain number, I don't have the number, I could set up with a micrometer. I could say, well, fine, then it can't be any bigger than, we'll say 0.5. Can't be any bigger than 0.5. So I would set this to 0.5 and say, all right, if it's bigger than 0.5, it's what? It's bad. So it can't be any bigger than that. So I put my little T gauge in there, set it up, and set my T gauge so it's exactly half an inch. So I'm reversing everything. So now, boom, my T gauge is exactly half of an inch. And so if this half inch can fit in here, then the guide is what? Good or bad? It's bad.
Too big.
So do I care what size it is? I could care less. Bad is bad. So if this fits in here, then that's worn too much. It's bad. I don't care how bad it is. It doesn't matter to me. I got to move on to the next one. I label it bad. Boom, next one. Fits, fits, fits. All bad, all being changed out. That's how fast I did it. Well, somebody else over there goes, well, wait a minute. Hang on a second. I got to measure it. Oh, good. Got the bottom. They're over here. It's like, okay, well, this one is 0.5, 7. And I'm like, well, I just did another set while you were doing that. You know, so that's a go-no-go gauge.
You don't have to record what it was at. You just have to say it didn't meet this spec.
Sure, I could put greater than 0.5.
Oh.
Okay, but then you also, at the other end, because you didn't know, what if it's too small? That could happen. And you think, well, no, it's going to wear. Well, sometimes you get carbon buildup and things happen. The last guy didn't do it right. So then you can do the opposite. Then you say, but it must be at least, and so I set this up. It's got to be at least this much. And I say, okay, this one needs to fit. So this one needs to fit, and this one better not. And believe it or not, in engine manufacturers actually make gauges like that. You have to calibrate them all the time. They're just fixed, a fixed rod or bar that's the exact right size. They call it a go-no-go gauge. One side better go, and you flip it around. That side better not. This side's painted red. This side's painted green. So it's not, like you can't do it. It's done all the time. So all right, go-no-go
Our work-
gauges.
But for our work, we have to put what it was.
You got to put what it is. Yeah.
So
dial
we have
indicator.
to, will we have to like record that into the 10,000ths of an inch? Or
Yes, I want them to
It's still
10,000.
away?
As best you can, yeah. All right, let me see. How are we doing here for time? Tomorrow's our ooh, man, what is tomorrow's Thursday? I'm in deep trouble with you guys. All right. See if I'll be talking fast tomorrow. All right, so that's going to be it for tonight. I think 'cause we're out of time.